Okay, as I usually do in class, I'll do things and then I'll ask you to work for time on something and um, ask you to kind of respond, indicating your progress with whatever it is I've asked you to do. Um, okay, that was it. Okay, now I've got plenty of space to work. Okay, so we're just going to start with a simple equation. Let's take the equation 5x equals 12. Okay, I'm just going to ask you to solve that. Then we're going to write down a couple more equations because I think people pretty much be able to do this one. But then we're going to get them a little more complicated just to get a good picture of how you solve linear equations in general. So I don't have much imagination, so I'm using 5 and 12 again, but differently. And then we'll have about 2x plus 7 equals 19. Let's just start off with those three and just let me know how you're doing. Let me know if you think you've got the solution to the first one. Just type in the chat, solve the first one. Tell me what the solution is. First one solution is 48.6 or whatever it happens to be. It's not 48.6. And then second one got a solution so-and-so. And third one. And then we'll talk about the form in which these things need to be written out. This might be a little redundant with some of the things we might have done last week, but we want to build it up step by step. So go ahead and let me know when you've got something and let me know if you have any questions at any point. I'll be monitoring the chat. Now I'm going to pause the video because this will be dead space for anybody that's watching the video, but I'm looking at the chat. And do let me know with each problem. Don't wait till you have all three of them. Tell me with each problem so I can kind of see how you're progressing. All right, now I probably haven't left myself enough room because I'm big on that. Let's just see. In order to isolate x, I can do at this point one of two things. Only two things you need to be able to do to solve the linear equation, which is multiply or divide both sides by the same quantity, or add or subtract the same quantity on both sides. In this case, I want to divide both sides by 5. If I divide 5x by 5, I'm going to get x. Okay, so I write 5x slash 5 equals 12 slash 5. Now, nobody here got the wrong answer. Everybody got the right answer. So I assume we did this, but be sure that you're writing out this step and then make yourself a note. You divide both sides by 5. Now you can abbreviate that, but right, the whole thing, you want to reinforce to yourself that you're doing something to both sides. Now, you could say divide both by 5, but say it to yourself till you're really sure you have it. Okay, then 5 is a factor of the denominator and it's a factor of the numerator. 5 is the denominator and it's a factor of the numerator, meaning it multiplies the rest of the numerator. So you can divide the 5 into 5, which gives you 1 and simply leaves you x. And x equals 12 fifths. And what we did was divide out a common factor. Now, some people call that cancellation. I've said in class, I think, that I do not like the word cancellation because people cancel things that they shouldn't. If you say divide out a common factor, then you're talking about what you're really doing mathematically. Cancellation is not a mathematical operation. Dividing out common factors is a mathematical operation. Okay? And canceling stands for that, but people lose track of the fact that canceling stands for a very specific operation and under very specific conditions and do it wrong all the time. Okay, well, let's move on to the second problem. And if you got a solution to that already, you can type it in. And I'll give you time to do that. And if you need a little more time to solve it, that's fine because I've been distracting you with my voice. Okay, as I said, I just got two solutions. They're both correct. So what do we do in this case? We can add, subtract, multiply, divide, same quantity, both sides. Now, often people will write this with a plus 5 here and a plus 5 here. I emphasize that we don't do that. We write plus 5 equals plus 5. And now we're adding two sides of, well, we're adding 5 to each. Okay, we're adding the equation 5 equals 5 to the equation x minus 5 equals 12. Adding 5 to the x minus 5 is going to leave us with x. Adding 5 to 12 is going to give us 17. So in pretty much one step, we get x plus 0 equals 17, and there's our solution. Now, to document the step, I'm going to say what we do here is we add a true equation. You eliminate minus 5. We didn't have room to write that out in one line. And I recommend at least half a dozen times you write that out. Remind yourself of what's really going on here because it's going to be important later. You have to understand the idea of adding two equations. So you get x equals 17. Now, we can check, okay, we can check our first solution. We plug in 12 fifths for x. We get 5 times 12 fifths equals 12. Excuse me. And it's worth doing that. Off to the side here. Check. Excuse me, don't know what's irritating my throat here. Okay, I write 5 times 12 fifths equals 12 with a question mark. And I like to put the question mark over the equal sign. Is it equal? Well, this is 60 over 5 equals 12 because we multiply 5 over 1 by 12 over 5. So we get that, and this is 12 equals 12, and we check it off. You want to be careful with your check. You don't have that many problems in an assignment. So each problem you want to think through in detail and write everything out in detail so that it sticks with you. Now, I don't think that this is going to be a problem for anybody who's attending right now on equations like this, but you want to get in the habit. Here we check. You replace x by 17. And then you're tempted to write the No, yeah. No, we know that 12 equals 12, and we put a check mark there. The check is a very important step because when you're solving a problem and you've got an error someplace in the problem, the check is going to tell you, and then you're going to go back and try to correct that error. And that's where you're going to learn something. You don't learn anything by getting wrong solutions and not realizing it. Now, in open math, of course, open math is going to tell you that you got a wrong solution. And you get feedback that way. But you're not always going to have a situation where somebody's giving you immediate feedback on the problem. And you need to be able to give yourself feedback by checking. Okay, so let's go on to the third problem. If you're tired of listening to me, you've probably already worked it just to keep yourself sane, and that's fine, no problem. But go ahead and solve this one and tell me what you got. Okay, very quickly got a solution, nice detailed solution. Came up with the solution x equals 6. And then just shortly after, somebody else said x equals 6. Okay, so I think you've got it. But let's go through the details and make sure you check. It's easy to check. If x equals 6, you got 12 times 6, which is 12. 2 times 6, sorry, is 12. And you add 7. 12 and 7 gives you 19. Well, it's going to check. But let's go through the steps. We're going to, first of all, add the equation -7 equals -7. And we know that's a true equation because we have exactly the same thing on both sides. So we add these equations and we get 2x here. 7 and -7 gives us 0. 19 minus 7 is 12. And then divide both by 2. 2x over 2 equals 12 over 2. We divide out common factors. And then we just divide. And by that, I mean, on the left-hand side, we divide out common factors. I don't want to write all that out. You'll go to sleep on me. Divide out common factors. On the left, the common factor is 2. And then just divide 2 into 12. That leaves us with x equals 6. We check. If we solve it correctly, then replacing x plus 6 ought to give us a free statement. Then it does, it gives us 12 plus 7 equals 19. 19 equals 19. Okay, now there people doing some work in the hall. So I'm going to pause this just for a second and just pull the door shut. I'm not sure that's coming through the microphone. But they're doing important stuff. They're laying some tile and it's a bunch of good guys and we don't want to interrupt them in any way. So give me a second here. Just got to walk over to the door. All right. Just somebody running a shop back down the hall. They're doing a small area, so I don't think they'll do too much of that. And I'm not even sure it was being picked up by the microphone, but just want to make sure you can hear. Okay. Now, let's get a little more complicated equation. Y'all are doing real well. So I'm going to skip a level of simplicity and see if we can jump to this. Again, if you have a question, which rule to use or anything, just throw it in there and I'll explain as we go. I'll give you a minute or two to solve that one. Okay, we have two solutions. One person just sent the raw solution. Another person showed every step. Okay, so the first step that we want to take is to use the distributive law to multiply this out. Now remember, I'm not talking just to the people who are attending today. There's another person in class who's apparently not able to attend today, who's going to get this video and needs to see everything. And there are distance students who need the same thing. So if I'm being a little pedantic for people who are doing this live, bear with me. Okay, so we're going to use the distributive law. That is, we're going to multiply 3 by every term in parentheses. What's a term? Something that's separated by a plus or a minus. Okay, so that means we're going to do 3 times the first term. And then we've got a minus here, so we kind of write that as a minus 3 times 7. We could also write that as plus 3 times negative 7, but it's easier to have a minus outside here. You do have to be careful about that. Until I see people making errors in that way, I'm not going to stress that too much. I think that is or should be pretty familiar to people. And if it's not, we'll modify what we're doing. Okay, so anyhow, there's a distributive law. I haven't left myself much room to write things out, but I think we'll get by. And then we do the arithmetic. In other words, 3 times 4x and 3 times 7. Well, 3 times 4 is 12. Multiply that by x, we get 12x. 3 times 7 is 21, and that's minus. Then we have x plus 5. Now we have a decision to make. Do we want to isolate x on the left side, or do we want to isolate x on the right side? Well, usually we want it on the left side. It might be convenient to isolate it on the right side, so we don't have a single x here, but eventually these x terms are going to combine. So we're going to just go ahead out of habit, more or less, and isolate x on the left-hand side. We're going to do that by getting rid of that 21, negative 21. So we're going to add the equation 21 equals 21. Add true equation both. Make sure if you write down an abbreviated statement that you think about what it means as you write it down. It will stay with you when you need it. Okay. So, well, we're going to get 12x over here. Leave the 12x here because the alignment can be important. I don't bother aligning 21 with the 5, partly because I've got room over here, but probably a good idea to align the 21 with the 5, just so you don't think you got to do something between the 21 and the x. However, if we add x plus 5 to 21, I'm going to back up. And I'm going to do this step a little differently because this is something else I really kind of want you to do when you get into an equation of this complexity. It's real easy to see things a little bit wrong and make an error, although nobody did. I'm going to write out what we get. We get 12x minus 21 plus 21 equals x plus 5 plus 21. And now we do the arithmetic. Okay, minus 21 and 21 gives us 0. So on the left-hand side, we just have 12x. On the right-hand side, we have x plus 5 plus 21. That's x plus 26. So now we don't have any plain numbers on the left-hand side. We just have x terms. Of course, we also have an x term over here on the right-hand side. We have 12x equals x plus 26. Okay, well, the 26 needs to be left on this side, but the x needs to go away. So we're going to add negative x equals negative x. I recommend you use the words add true equation, both, thinking, understanding that both means both sides. Get that firmly in your brain. And now I'm going to write out what we get. We have 12x on the left-hand side. We have negative x on the right-hand side. So that's going to give us 12x minus x. I'm sorry, we have 12x on the left-hand side of the first equation and negative x on the left-hand side of the second equation. When we add those, we get 12x minus x. On the right-hand side, we have x plus 26 in the first equation, negative x in the second equation. So we have x plus 26 minus x when we add those two sides. And then we do the arithmetic. And we get 11x equals 26. So it looks like we're going to get a solution that agrees with the solution everybody got to this problem. So 11x equals 26. We're going to now divide both sides by 11. It's going to give us 11x divided by 11 equals 26 divided by 11. We divide common factors. And that leaves us with x equals 26 over 11. Now I am going to go ahead and do the check on this because it allows me to illustrate another important thing you can always do with equations. Move the board over just a little. Give you a good angle on it. Okay, so we plug in 26 over 11 up here. That gives us 3 multiplied by 4 times 26 over 11 minus 7 equals 26 over 11 plus 5. Well, I'm going to multiply through by 3 here. I'm going to do it in a couple of extra steps. 4 times 26 over 11 can be multiplied out. Think of that 4 as 4 over 1, and 4 times 26 is 104. On the right-hand side, we'll keep things 26 over 11 plus 5. Now, at this stage, people tend to want to put everything over the common denominator 11, because, of course, that's how you add fractions. And that's a perfectly good instinct, but you don't need to do that when you have an equation. We'll see that after the next step. So what we do is we use the distributive law. And there we are. 3 times the 104 over 11 minus the 3 times the 7. And the right-hand side is still 26 over 11 plus 5. Now, 3 times 104 over 11 is 312 over 11. And I hope I'm getting my arithmetic right, because if I'm not, this thing isn't going to work out. So the 3 times 104 over 11 gives us 312 over 11. minus 3 times 7 is minus 21, and that's equal to what we had before, 26 over 11 plus 5. Now, you still might have an inclination to get a common denominator, but you don't have to do that. We can multiply both sides here by 11. Numbers are going to get a little bit big, but they're going to get a little bit big if you try to find a common denominator. Okay, so 11 times the entire left-hand side. So left-hand side is 312 over 11 minus 21. We now multiply that by 11. We get 11 times the quantity, 312 over 11 minus 21. And that's equal to 11 times the right-hand side, which is 11 times the quantity, 26 over 11 plus 5. Okay, now here's where it gets kind of neat. We're going to have 11 times 312 over 11. Now you see that 11 is the denominator and it's a factor of the numerator. At least I'm going to write it out in one more step to make sure we see that. But you see where this is going. This 11 is going to divide this 11 and go away. And this 11 is going to divide this 11 when we get done, and it's going to go away. Now, the price we pay for that is we've got to multiply 11 times 21. So what we have when we multiply both sides by 11, again, 11 times the quantity, 312 slash 11 minus 21 equals 11 times quantity, 26 slash 11 plus 5 quantity. Okay. After the distributive law, we have 11 times 312 divided by 11 minus 11 times 21. And that equals 11 times 26 over 11 plus 11 times 5. I'm going to rewrite this slightly. So I'm going to change the 11 in front of 312 over 11 to 11 over 1. I'm going to change 11 in front of 26 over 11 and write that as 11 over 1. That way I have both a numerator and a denominator, so I can multiply numerators and multiply denominators. Now, 11 times 312, well, everybody knows that's 3,120 plus 312, which should be 3,400. Okay, 3,120. We had 300. We get 3,420. So that's going to be 3,452. If I've got it right. And the 11 here divides the 11 here. We see we're going to have a factor of the denominator, factor of the numerator. I say here, 11 over 1 times 312 over 11. It's going to give us 11 times 312 over 11. The 11 in the denominator divides the 11 in the numerator, which is a factor of the numerator. Then we subtract 11 times 21, and that gives us 210 and 21, which is 231. And I hope I have the numbers right. Okay, then on the right-hand side, we have 11 over 1 times 26 over 11. Again, 11 is going to end up as a factor of the numerator. 11 is a factor of the denominator. And, I did something really dumb over here, so I'm going to have to fix it. But we end up with 26. Then 11 times 5 is 55. So again, on the right-hand side, 11 over 1 times 26 over 11. The 11s divide out. I get 26. I get 11 times 5. That's 55. And my chat ought to be lighting up and saying, hey, bonehead, you did something wrong. Okay. Now, I get carried away with the arithmetic. I multiplied the 11 times the 312. And that's totally wrong because I left the 11 off. Now, I could have written that as this over 11. Okay, that is 11 over 1 times 312 over 11 in the preceding step. I multiplied the numerator, got 3452. That's probably right, but maybe not. And I did that after saying, well, the 11 divides the 11. It just leaves me with the 312. Okay, so again, 11 over 1 times 312 over 11 is just 312. So my left-hand side is 312 minus 11 times 21, which is 231. Right-hand side, 11 over 1 times 26 over 11 is just 26, and then plus 11 times 5, and that's 55. Okay, so now if I subtract, well, let's add 26 and 55, that's 81. And if I subtract 231 from 312, that gives me 81. So my equation 312 minus 231 equals 26 plus 55 just becomes 81 equals 81. And by darn, we've not only got it right, but despite my attempt to screw it up by a bad step, I discovered that step and corrected it. And except for that little glitch, everything went smoothly. We got 81 equals 81. Now, this is a big deal. When I have denominators in a fraction, when I have denominators in an equation, I can, at this stage, when it's just numbers, I can always multiply both sides by a common denominator, and that wipes out the denominators. You see that multiplying both sides by 11 here in the fifth step had the effect of wiping out all the denominators, and I never had to worry about fractions again. Now, maybe in the last step, sometimes you get a fraction because you got to divide by something, but that almost always works when you're solving an equation. Now, there's one caveat. When we get to rational expressions, there are variable expressions that can sometimes equal 0. Well, we can't multiply both sides by 0, so we have to worry about that a little bit, but that's not an issue here and won't be for a little while, at least half the course. And when that becomes an issue, we'll talk about it. Okay, so this equation was a little more complicated, and the check was a little less straightforward than the others. But you want to be able to do this, and you want to be able to do these steps. Of course, you can punch the fractions into a calculator and it'll tell you everything comes out equal. I say that's something you want to avoid while you're working on this course so you get a better sense of the arithmetic. Okay, well, let's do another equation. People are doing real well with this. Things too crowded up here. Okay. Let's try this one. And it's about as complicated as they're going to get unless we throw in fractions. And I'm not going to throw in too many fractions right now. We'll probably do one more involving fractions, provided we have time. So let's take 4 times 3x plus 9 plus 5x equals 7 times 2x minus 3 plus 4x minus 6. Bunch of terms here, but things simplify. So keep your wits about you. I recommend that you simplify each side before you try to do anything else. Use a distributive law, multiply everything out, then add all like terms and so forth. And if you could just tell me, just submit what you get when you simplified both sides, then we can address any problem that might come with that simplification. But before you go on. Now, if you get it down to both sides, then you can do the subsequent steps. But we want to check that we simplified both sides correctly before we go on. Well, you can go on. Before we go on in class, we'll check and make sure that we have both sides correct. Okay? You got any question what I just said? If that's confusing, give me a question, say, hey, can you say that all again? And I'll be glad to. Okay. Okay, if we multiply through here, I'll do this rather quickly this time. The 4 times the quantity 3x plus 9, the equation is 4 times the quantity 3x plus 9, the quantity, plus 5x equals 7 times the quantity 2x minus 3, the quantity, plus 4x minus 6. First thing we want to do is simplify the left-hand side. We use the distributive law to multiply the 4 by the quantity 3x plus 9. And we get 4 times 3x plus 4 times 9. And then we still got the 5x on the outside of that parentheses. So there's the first step in simplifying the left-hand side. And I'll continue simplifying the left-hand side because I'm not going to mix the sides until we have everything as simple as we can get it. So we have 4 times 3x is 12x plus 4 times 9, which is 36, plus 5x. So there's the next step on the left-hand side. Okay. So now we have 12x plus 36 plus 5x on the left-hand side. We have to add the 12x and the 5x, and that gives us 17x. We still have 36. So the left-hand side gives us 12x plus 36. I think I saw one solution that had a 12x there instead of a 17x, and that 5x apparently, fell off the wagon or somehow maybe got moved to the other side or something. So, but if we simplify the left-hand side without even looking at the right-hand side, we end up with 17x plus 36. On the right-hand side, we have 7 times the quantity 2x minus 3, the quantity, plus 4x minus 6. Multiplying the 7 times the quantity 2x minus 3, we have 7 times 2x minus 7 times 3. And then we have 4x and 6. Okay, so we have 7 times 2x minus 7 times 3 plus 4x plus 6. That gives us 14x minus 21 plus 4x plus 6. And now we do the arithmetic. And also, when you're working these for homework, I'm not going to take the time now because I want to see if we can get to this last problem. You write out what you're doing in each step, okay? The 14x and the 4x is 18x. Negative 21 and 6. Oh, that's negative 6. Okay. I made a mistake. I had a minus 6 at the end of the second, at the right half, on the right-hand side of the equation, and I carelessly wrote that as a plus 6. I did this in my head a while ago, and I got what I think is the right solution, but we'll see. Okay, so I wrote a plus where I should have written a minus, but now the right-hand side ends with a minus 6 in both cases. We have minus 21 minus 6, which is minus 27. So I believe we have 17x plus 36 on the left and 18x minus 27 on the right. So we need to be very careful. And there were a couple little errors. So that's why I wanted to stop at this point and make sure everybody was on track. Okay, if you have any question on that, please just type it in. I'll read it and respond to it. Not saying anything so far, but it takes time to type if you got a question, if you're not sure about something. Okay, now we're going to, now we're just down to a simple equation like the ones we've seen before. We're going to try to isolate x on the left-hand side. So we're going to add, here we have 17x plus 36. We're going to add negative 36 equals negative 36 to the equation. And it's going to leave us with 17x on the left. And on the right, it's going to be 18x minus 27 minus 36. Negative 27 minus 36 is negative 63. And now we're getting real close, but we have x's on both sides. So we want to add the equation negative 18x equals negative 18x. Why is that? It's because we have an 18x on the right-hand side. And we don't want it there. We want all the x's on the left-hand side. Now I'm going to write out the step that we get here. We get 17x minus 18x equals 18x minus 63 minus 18x. When we do the arithmetic, on the right-hand side, 18x minus 63 minus 18x. The 18x minus the 18x just leaves us negative 63. 17x minus 18x is negative x. And I think that's correct. If we multiply, well, we're going to multiply both sides by negative 1, we're going to get x equals 63. Now that does differ. From some of what I saw, so I want to make sure that I didn't do anything wrong here. It's easy to, if you add the 18x to the 17x, you're going to get 35x and you're going to get negative 63 over negative 35. So let's trace where that negative 18x came from. 7 times 2x in the first step gives us the 14x we have in the third step. And then we have a plus 4x, and that gives us 18x. On the left-hand side, we check that pretty carefully. The 4 times the 3x gives us 12x, and our 5x is still there, and that gives us 17x. So it appears that this is going to work out. So I multiply both sides by negative 1. I'm going to write that out because we haven't done that before. Multiply both sides by negative 1, we get negative 1 times negative x equals negative 1 times negative 63. So that the negative x equals negative 63 is going to become x equals 63. Now I'm going to just kind of check that out in my head real quickly. 3 times 63 is 189, and 9 is 198, if I'm doing this correctly. 4 times 198 is 32 less than 800, so 768. 2x would be 126, that's 120, that's 840. And we add 242. We get 942 minus 6 is 936. I think that's what I said I had on the left. So I kind of think that that checks. Okay. I'm looking at the time, and I want to quickly get to this problem. You want to check this solution. There were a lot of steps in this problem. It's very easy to make a mistake. You see me make mistakes. And I used to know what I'm doing. I think I still do, but who can tell? I'm not the one to judge. Okay, so we check this. And let me see if there are any. Okay, if somebody said they accidentally forgot the 5x, yeah. Well, you saw me write a plus 6 when I had a minus 6. And if I hadn't looked at it before in my head, I probably would have gone on with that and gotten the wrong solution. Would have done all the rest of these steps correctly, presumably, gotten something that didn't check, and then I'd have to go back and figure it out. Okay, so you always want to check. If you were doing this problem on your own and didn't know what the answer was, and nobody's telling you whether it's right or wrong, and that's going to be the case when you take a test. You got to know how to go back and find your solutions, find your errors. And in mathematics, we make a lot of errors. We have to be able to find them. And when we find them, we learn something important. Okay. Now, make sure my clock is synchronized. We got 6 minutes. And 6 minutes is actually going to be plenty on this problem. Okay. Now I'm going to rewrite this problem. Oh, knocked my spray can off when I moved the board a while ago. And I know you missed seeing it there. Again, this new equation, 7/6 plus 2/3 equals 5/8. This has denominators. Matter of fact, it's got 3 of the darn things. What's a common denominator? Well, it should be clear that between 3 and 8, 3 and 8 don't have any common factors. So our common denominator has to at least have 3 times 8, which is 24. It's also got to have x, because x is a denominator. Okay? None of these denominators can be said at this time to have any common factors. We don't know what x is. Might turn out that x has a common factor with 3 and or 8. It's kind of likely because a lot of numbers have 2 and 3 as factors. We don't know that yet. And actually, it's highly likely that the solution to this equation is going to be a fraction. So, and my whole point is, you have to treat x as not having any common factors with any of the other numbers, unless you already know what x is, and then it would be pointless to solve the problem. Okay, solve the equation. Common denominator is going to be 3 times 8 times x, which is 24x. Now that's our part. The easy part is we just multiply both sides of the equation, which means that we multiply the common denominator 24 by the whole left-hand side, 7 over x plus 2/3. Very common error is people multiply the 24 by the 7 over x, but not by the 2/3. Multiply it by the first thing you see, you forget about the second thing. Just like I forgot about the negative sign, I didn't forget. I just wasn't looking carefully. But anyhow, we do that, and it should be 24x, not 24. Almost made another mistake. Okay, so then we have 24x times 5/8. So we multiply both sides. CD stands for common denominator on both sides. And I'll put a little whole side, the whole side, group the whole side, and there you have it. Okay, so that gives us 24x multiplied by 7 over x. Okay, 24x multiplied by the quantity, 7 over x plus 2/3 quantity, gives us 24x times 7 over x plus 24x times 2/3. And I'll just write out the right-hand side the way it is right now. 24x times 5/8. Now, every 24x, I'm going to write as 24x over 1, just to remind myself that the 24x is going to be in the numerator and the 1 is going to be the denominator. So the 24x multiplied by 7 over x becomes, I'm just going to multiply it up. 24 times 7 is 168 x over x plus 24x times 2 is 48x. Multiplying the 24x over 1 by the 2/3, the numerator is going to be 24x times 2, which is 48x. The denominator is going to be 1 times 3, which is 3. And on the right-hand side, 24x over 1 times 5/8 is going to give me 120x when I multiply the 24x by 5 over 8. Now you see I've got x's in the numerators and x's in the denominators. My term 168x over x, x is a factor of the denominator, it's a factor of the numerator. I can divide the x into the x, leaves me 168. Then I have 48x over 3. 3 goes into 48 16 times, that gives me 16x. 120x over 8, 8 goes into 120 15 times. So I have the equation 168 plus 16x equals 15x. Now we're out of time, so I'm just going to write etc. here because I've illustrated what I need to illustrate. This equation is very simple. You don't have to do any fractions. And actually, we do end up with x being a whole number. It's going to be negative 168, I think. I said earlier, I figured x would probably come out to be a fraction, but it didn't. So if I have negative 168 here, 7 over negative 168 added to 2/3 equals 5. That doesn't check. Because, no, wait, 2/3 is a little bigger than 5/8. 7 over x is going to be kind of small. So we're going to have something a little less than 2/3, and 5/8 is a little less than 2/3. So I think it probably does check, but you can check that, and I recommend that you do. Okay. Well, thank you. It's 12:21. If you have any questions or comments, go ahead and insert them. But I'm going to need to close this down in about 4 minutes so we can have the next class. And if you still have a question after that, put it in the email, and I should be able to respond this afternoon. Thank you for being there, and thank you for participating. Everybody did real well. So again, I'm going to keep this open so I can see any questions that might come up or any comments. And if you're going to leave, say goodbye. You don't have to. You can just close out and the chat will show me. So you don't have to wear your fingers out saying goodbye. It's implicit. But if you want to, that's okay.